back to the channel. In this video, we're going to talk about the calculation of percentage abundance related to atomic mass of elements with various isotopes. And by the end of this video, I'm going to give you a gift, like something that contains all the exam possible questions, and I'm going to tell you how to get that. Because as a JAM students, you need to what master this one here. They get all the exam possible questions. So make sure you stick to the end of this video. And secondly, make sure you have your pen, your notebook, and your calculator to follow through what we are going to do in this video. After this video, once you get the gift I'm going to give to you, then you have to what solve this question. You get, so let's get started. So when the question is being given to you like this one is under isotope what calculation, and we have different method in what solving isotope, like calculating what the atomic mass of element with what various what isotopes. So I want to give you the formula method because I love using the formula method, because with the formula method you don't need to crack your brain. You just need to what input your values in from the question into the formula and what get your answer. So let's start with the formula. Here we have RAM. So called relative atomic mass. So you can also call it atomic weight or relative atomic weight. Together, they're all the same thing. Equals to A1 times P1 plus A2 times P2 plus A3 times what P3 over what P1 plus P2 plus what P3. So now let's start defining all these ones here. Let's start defining them. So my RAM is called relative atomic mass of the what element, or the relative atomic weight of what of the elements. Now A1 is the what the atomic weight of the first isotope. So here you can say atomic weight or atomic mass of first isotopes. First isotope, you get. Then A2 equals to what? Atomic weight, or sorry, atomic mass of what? Second isotope. Then the third A3 equals to what? Atomic weight. Oh, sorry, atomic mass of what? The third what? Isotope. You get. Then P1 equals to what? Percentage abundance. Percentage abundance of what? First what? Isotope. Then P2 will now be what? Percentage abundance of what? Second isotope. P2 will now become what? Percentage abundance of what? Of the third what? Isotope. So with these parameters here, you can easily solve any questions like this question you are seeing displayed on the board here. So here we have RAM equals to A1 times P1 plus A2 times P2 plus A3 times P3, all over what? P1 plus P2 plus P3. Now, remember P is what is the percentage of abundance here. And what you want to put in your mind is that P1 plus P2 plus P3 is always equal to 100%. Now, this is when the element contains 3 isotopes. Do you get that? But if it's 2 isotopes, it's going to be P1 plus P2 equals to 100%. It means that when the percent abundance is given to you, it means that when you sum all their relative abundance, it must give you what? 100. And secondly, here, the atomic mass of the A1, A2, A3 called the atomic mass. The unit is known as what? AMU, called atomic mass unit. AMU, we call atomic mass units. Do you get that? So with this information, you can easily solve any question related to what isotope what calculation, and I'm going to teach you how you can apply this formula to solve questions like this or more. You get. Then by the end of this video, download the PDF I'm going to share with you for free. Then we have other questions there. You get, so that you know that you are done with what isotope. You can now move to the next stage. The first one here, you see that oxygen is a mixture of what two isotopes. It means that oxygen has what two isotopes, right? So isotope 16 and what isotope what 18. Now with relative abundance of what 90% and what 10% respectively. What is what relative mass of what oxygen? You get so solution. So that is my A1 is what is going to be the atomic weight of what oxygen here A1. So A1 equals to what 16. Then A2 equals to what 18. Do that 18. Then P1 that is the relative abundance of the first isotope result is 90%. 90%, right? Then P2 is equals to what 10%. You find out when you sum two of them, it gives you what 100%, right? So if you, now what I ask you to look for is what relative mass of oxygen. So you are looking at relative atomic mass of the what elements here. So when you apply the formula I gave to you, so RAM is equal to what? A1 times P1 plus what? A2 times P2. Now there's no A3, so you have only twice two. So here we have P1 plus what? P2. So what I want to do here is what? Input your values and what? Get your answer here. My A1 here is 16. 16 times what? 90, right? Plus 18 times 10, sorry, over 90 plus what? 10. So you have to what? Use your calculator to what? Get your answer. Give what? Equals to what? 16.2. That is what? That is the answer. So as easy as what? As that. So the next one to do is what? Use the same method here to get to solve our second question. Now, the second question look like what the first question. You look at the question, see that an element X which related atomic mass of what 16.2. It also the same thing here, they just change the stuff there. Now, an element X with related atomic mass of what 16.2 contain two isotopes here, 16 and what and N. So you say that we only know the relative relative mass of the first isotope, but we don't know the relative mass of the second isotope. Do you get that? Now that I say what is the value of what of M? What is the value of M? So each of them have their own what percentage abundance. So it's essentially a solution. Solution here we have so going to be A1. A1 is equal to A1 is equals to what 16. A2 is equals to what M. This is what you're looking for. Do you get that? Then P1 is equals to what? What is P1? P1 is what? 90%. P2 equals to what? 10%. This is that. Now, the relative mass I'll give it as what 16. So atomic mass. So relative atomic mass is already given to us as what 16.2. This is that. So this is what we are going to use in one calculation. So if you should use what the simple formula I'll give to you, relative atomic mass equals to what? A1 times P1 plus what? A2 times what? P2 over what? P1 plus what? P2, right? So what I want to do now is so input what our values. So this is what is 16.2 equals to what? A1 is what 16 times what 90 plus what M times what 10 over, if you add it together, you're going to give 100. So let's evaluate it. So what are you going to do here? So when you cross multiply 16.2 times 100 it will be 1620, right? When you cross multiply equals to, when you multiply this one here 60 times 90 1440 plus 10 what M. You get that? So if you make M square formula here, we have 10m equals to 1620 minus 1440, right? So here we have 10m equals to 180. So make it M square formula. Make M square formula here. Here we have m equals to 180 over 10. Here we have 18. So you can see how easy it is. You want to look at two more questions. Then, so the next one we are going to look at what calculation of what percentage abundance and more than one, so that you will be able to what understand this stuff here. Now let's look at what these two questions. They are similar to the one we have done. So pay close attention. Now the third one is what an element X has two isotopes, isotope 20 and another isotope 22, present in the ratio 1:3. Calculate the relative atomic mass of X. You see, so this one is what is giving in terms of what of ratio. It's giving in terms of what of ratio. So what I want to do here is to what I want to do here now the place of what percentage P. I want to put what arrow, right? So normally relative atomic mass is equal to what A1 times. It's supposed to be what P1. So but it's going to be what arrow what 1. This arrow 1 means what the ratio plus A2 times what arrow what 2 over what arrow 1 plus what arrow what 2. This is that. So it's very easy. So what I'm going to do now, I'm going to impute my values straight. So here we have arrow AM equals what my relative atomic mass of the first one is 20. So it will be 20 times the ratio is what is 1. So it will be what 1 plus A2 is what is 22 times 3 over what I want to do to sum there. So it's going to be 1 plus 3. You get that? The answer now when you pitch this one in your calculator, I want to get 21.5. There is the answer. As easy as that, right? So let's look at what the last one in this video, question 4. 4 is a little bit different from what we are doing, but it's still the same question. Chlorine consisting of what two isotopes of mass 35 and what 37 has an atomic number of what 35. So the relative atomic mass of chlorine is what 35.5. So our A1 and A2 are what 35 and what 37. So it means that A1 which is what chlorine 35 is okay, is what 35 is okay, 35. Then A2 which is what chlorine what 37 is also what 37. Just that. Remember, I also have what my P1 and what P2. But then they are asking us to what look for the great abundance of what 37. So it means that I don't know P1, I don't know what P2. Do that. I don't know P1, I don't know what P2. So how am I going to do that? Remember, P1 plus P2 is always equal to what 100, right? P1 plus what P2 is always equal to what 100%. Do you get that? It means that if I'm to look for what the relative abundance, if I can equate here to be X or Y, then here is now going to be what 100 minus what Y. You get? So you always equate the first percentage to be what 1. Percent abundance to be what 1. So now you now say let P1. So you can now say let P1 equals to what Y%. If P1 equals to Y%, remember P1 plus P2 equals to 100, right? If you make P2 instead of formula here, what will go to happen here? P2 go to do what 100 minus what P1, right? Or in percentage. So remember my P2 go to be what 100 minus uh, uh, P1, P1 is what is Y. So going to be what? Y percent. Do you see that? So it means that if I can what look for what my Y, there is already calculated what P1, right? If I can look for what, then from there I can really get for my P2. That Y you have got to, or you are going to get in the question from the calculation is total for 100. So that's how you get what P2. Do you get that? So you have to what impute your formulas. So remember, ROA is equal to what? A1 times P1 plus what? A2 times P2 over. Remember, P1 plus P2 is going to give me 100%. I'll just put 100% here, 100 here. So what I want to do here is to increase your value. Remember, this guy is going to me to be what? 35.5. 35.5 equals to my A1 is what? Is 35 times Y. They don't want to put it percent again because it's already over plus over what 100 plus A2 is what 37. Now P2 is what 100 minus Y, so going to be times 100 minus what Y over what 100 over what 100. Hope you understand. So for the formula here, for the question, I've gotten my parameters, right? Because they're asking us to look for P2, which was the percent, the little abundance of what 30 what 7. But I equated what my P1 to be what Y. So my P is now going to be 100 minus Y. So since I've got all this one here, I have to what, impute my values into what the formula. Then what I'm trying to do now, I'm now going to try to evaluate what Y or solve for Y. If I can evaluate for Y, then I've actually what gotten the answer. Hope you understand. Then let's evaluate it. I want to buy this one. So the next one to do here is to what cross multiply. Just cross multiply. So when you cross multiply, you're going to be what 3550. 3550. This is the reason why, because it's going to be 35.5 times 100. It's going to have 3550. 3550 equal to 35 times y. Going to be what? 35y. This is that plus. So going to be So it will be 35 times 100, because when you open the brackets, it's going to be 35 times 100. No, going to be, no, I wish I could problem with this one now. 37 times what? 100. 37 times 100. So going to be 3700. So going to be 37 what? 00 minus 37 what? Y. Do you understand? So what I want to do here is open up the brackets. So what you want to do is open up what the brackets. So when you open up the bracket, here we have 33550 equals to what? 35y plus 3700 minus 37 what? Y. Do you see that? So that's what I want to get here. So what I want to do now is what cross collect like collect what like terms. So here we have 3550 minus what 3700. 3550 minus what 3700 equals to 35y minus what 37 what y. When you subtract it, here we have going to be what? Minus 150 equals to, here we have what? Minus 2y. Minus what? 2y. So if you should make y itself formula here we have, we always have a minus 2. Minus what? 2. So 2 cancel out 1 here. So here we have 150. Here we have what? Y equal to be what? 75. Y equals to 75. You get? So it means that, remember, I want to write this place here. Remember, my P1, P y equals to what? Y percent equal to, my y is already what? 75, going to be 75%. Do you get that? P2 equals to what? 100 minus y in percent. So it's going to be 100 minus what? 75. Equals to what? 25%. It means that my percentage abundance for my percentage abundance for chloride 37 is what? 25 what percent. Do you get that? And percentage abundance for what? Chloride 35 is what? Is 75 what percent. You get? So this is how you can what? Solve questions relating what? Percentage abundance. You get percentage what? Abundance. And you need to practice. You need to practice yourself. So I've compiled all the questions they've ever asked in JAM related to what? This topic. So how do you get that? It's very easy. It's free. Go to the description below. You see a link that will take to download that free PDF. So that is your bonus of you staying to the end of this video. Make sure you go download it. It's free. Then solve those questions. Now, if I have topics on JAM I've done here, so you can go here. I will click on the ones you like to watch. We'll see you there.